Hello. In our previous lesson, we have looked at the linear function. We've mentioned that for linear functions, we are looking at those type of functions that exist in a straight line or that exist on the rate of change, which are constant, right? So when rates of change are constant, then we have linear functions. My name is Nana Edu, and you can call me Say Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In this lesson, we want to consider the gradient of a function. We want to look at how we can find the gradient of a function and what it means to talk about the gradient or the slope of a function. Now, let's look at the gradient of a function. So basically, with the gradient of a function, we are considering the m parts of the equation. So if you have an equation that is of the form y is equal to m s plus c, then we are considering the m part of the equation. So for instance, y is equal to 2x plus 3. It means that the gradient here will be 2, right? So the gradient will be 2. And that 2 also represents the slope of the line, right? So when we talk about slope of something, we want to basically look at how smooth, right, or how rough that thing is, how it is moving in terms of a gradient. So we are looking at the slope of the line, right? So to find the slope of the line is basically a rate of change that looks at the difference between the y and the x. So we see that the gradient is a change in y all over change in x. So you can represent the gradient as 2 points y2 minus y1 all over s2 minus x1. Or in other ways, we can also write it the other way around, right? And have the gradient m to be equal to y1 minus y2 all over x1 minus x2. Remember that we cannot write it in this way, y1 minus y2, and go and write x2 minus x1. That will not give us the gradient. So the gradient is when you use y1 at the top minus y2, you must ensure that for the denominator part of the question as well, or of the gradient formula as well, we must use x1 begin from the 1 to the s2. So basically, let's look at how we can find the gradients using this graph. So when you have this graph, you see that there are 2 points, right? So you have a point here and you have a point here. And the coordinates of the point here for this line is 2, 0. And then the coordinates of the point for this line is 8, 3. So to find the gradient or the slope m, we know that that should be y2 minus y1 all over x2 minus x1. Now we can label this as x1 and label this as y1. Then we can label this as x2 and label this as y2, right? So it means that our y2 becomes 3 and then our y1 becomes 0. So we have 3 minus 0. And then our x2 becomes 8 and then our x1 becomes 2. So 8 minus 2. So it means that 3 minus 0 gives us 3 and then 8 minus 2 gives us 6. So it means that we have a gradient that is 1 over 2, right? So what does it mean when the slope or the gradient of a line is greater than 0 or is positive, right? Or is positive, right? So when a gradient is greater than 0, as we have in this case half, or is positive, you realize that the line will be strictly increasing. So we see this line is moving, right, from the negative part to the positive part. So we say it is strictly increasing. So what happens is that the line is strictly increasing, right? So take note that anytime that the gradient is positive, then the line is strictly increasing. Now let's look at another example. In this case, we have 2 points, right? So one point is 1 comma negative 2, and then we have another point which is on the line which is negative 1 and 4, right? So we say that we can also find the gradient of the line m to be equal to y1 minus y2 all over x1 minus x2. Remember that any of these whether y2 minus y1 all over x2 minus s1, or y1 minus y2 all over s1 minus s2 gives us the same value. So we could call this x1 and have this as y1, then this x2 and then y2. So it means that we are using y1 first. We are minus 2 minus 4, right, all over the x1 1, right, minus 1. So that implies that we have minus 2 minus minus 4 gives us minus 6. Then 1 minus minus 1 gives us 2. So negative 6 all over 2 gives us negative 3. So it means that the gradient m is equal to negative 3 as we have over here. And what does it mean when we have a negative gradient, right? Or when the gradient m is less than 0, or when it is negative? We see that the line or the equation is strictly decreasing. So we realize that it is moving from the positive side towards the negative side. So we see that when the gradient is negative, right, when m is less than 0, then the line is strictly decreasing, right? So we see that when the m is greater than 0, then the line is strictly increasing, and then when the m is less than 0, then the line is strictly decreasing. Now, try and solve this question. What does a zero slope graph looks like, right? So we want to find out what a zero slope graph looks like. So when we find our gradient, right, and the gradient is not negative or it's also not positive, but then it's 0, what would they look like? So describe that in the comment section for me. Let us discuss that. Let's have fun by looking at what a zero slope graph or a zero gradient graph looks like. So in this lesson, we have looked at how we can find the gradient of a function, and we mentioned that to find the gradient of a function, it is the rate of change of the y to the rate of change of the x. And we have mentioned that to find the gradient m, it is y2 minus y1 all over x2 minus x1. Once we have a gradient that is positive, we know that then the graph is strictly increasing. And then once we have a gradient that is negative, we know that the graph is strictly decreasing. Remember to like this video, share this video, and subscribe to my YouTube channel. In our next lesson, we want to look at the area enclosed by a linear graph. See you in the next lesson.